quadratic regressions. We have already done linear regressions, and if you don't remember the steps to doing a linear regression, then you should look back in your notes, maybe put a tab there. If you look back to the beginning, I'm on page 14 myself right now, so that means that was early in the beginning. We performed linear regressions. The steps are right here. Step 1, entering your data. Step 2, making a scatter plot. Step 3, performing a regression. We're going to go to Stat, edit a list, number 1. If your lists need to be cleared, remember that you just scroll up on L1, hit clear, and come back down, and it will be cleared. So list 1, 0, 2, 6, 9, 12, 13, and 15. Going over to list 2 for my Y values, 4, 8.4, enter, 12.1, enter, and so on. Let's see, I'm just checking my list. They're all paired up with each other, and I'm going to quit. The next thing that we are going to do is we want to look at that statistics. So we're going to go to Zoom, and number 9 is Zoom Stat. Zoom in on your stat. There it is. Now I would like to create an equation of this. And it's a quadratic. We can see that it's got a parabola shape to it. We go to statistics. Now we want to calculate something about the statistics. So I'm going to scroll over to calculate, and we've done linear regressions. We're going to go on to quadratic regression. Number 5, list 1, yes. List 2, yes. We'd like to store this equation in y equals so that we don't have to manually punch it in. So we're looking for the y variable. We're going to go to vars for variable. We're looking for the y variable. Scroll over. Yes, it's a function. That's all you're working on this year are functions, and there are all the y's in the graphing. So we're going to hit y1. Now it's going to store the equation y1, enter, calculate. We're going to write down some information here, like about r squared. We can see that r squared is close to 1, so this is going to be a good fit. Find the quadratic equation for the relationship of the horizontal distance and the height of the ball, round to 3 decimal places. So distance in feet, height in feet. Our equation is going to be y equals ax squared plus bx plus c. And we can see our a, b, and c. Y equals a is around 3 decimal places. A is negative 0.118. X squared. B is positive, so plus 2.112. And C is positive, so plus 4.215. Using this function, what is the approximate maximum height of the ball? What is the maximum height? So let's go to graph. There is the equation that we just stored. If we look over here at y1, at y, we see that that equation has been stored in there. It goes many, many decimal places. Even more exact than just punching in 3 decimal places. There's the x squared plus 2.12 and so on. So back to the graph. We have a graph, and we can see that it is going up, coming back down. It's asking for the maximum height of the ball. We're looking for the maximum height. So if I do calculate here on the main screen, calculate, second, trace. What are we trying to calculate? A maximum, number 4. It's asking for left bound, so I need to be on the left-hand side. I'm just going to scroll over a little bit more, hit enter. Now I need to be on the right side of where I think that maximum is. We can see that here's an arrow that's saying we are starting here to look for that maximum. When I hit enter again, another arrow comes up. So that's looking between these 2 arrows. Hit enter again, and we get that the maximum is at 8.95 and 13.67. So this is, we'll say 8.96 and 13.68. What is the maximum height of the ball? The maximum height in feet, we see that all the answers are in tenths. So we're going to say maximum height of the ball is 13.7 feet. Go to y equals, clear the equation, go to stats, edit another list. I'm going to go up on L2, clear and come back down and clear my list 1. All right, the table shows population of a city every 10 years since 1970. Find the best fit quadratic model for the data, round 3 decimal places. Using this model, what will be the estimated population in 2020? Since 1970, so 1970, 1980, 1990, 2000, 2010, and 2020 would be 50. All right, we're going to enter our data in. Zoom 9 for Zoom stat. We are going to get an equation, stat, calculate, quadratic regression number 5, list 1, list 2. We're going to store that variable, bars, y variable, function, and y1. Enter, enter, write down that equation. Y equals 1.209 x squared plus 12.999 x plus 504.257. Using this model, what will be the estimated population in 2020? We are looking for 50 here. We could, let's see, graph. We can see the population is going up. Now, if I calculate when x is 50, it needs to be in my window range. To calculate when x is 50, it needs to be in my window range. Let's take a look at the window. Our x max, we can see, is only going up to 44. So if I tried to do that, let's just say I want to calculate a value. Number 1, I'm calculating an x value. If I put in 50, it's going to say error because the dimensions are invalid. It's not on my screen. So if I go back to my graph, quit, go back to my graph. If I look at my window, all I have to do is raise my window up to make sure the x value will be there. Let's go to x is 60. Now it's going out to where x is 60. Let's see if that works. Do I have to change the y value as well? We are going to calculate a value. Number 1, we'd like to see 50. And it says when x is 50 that we get 4.1774. They've got whole numbers in the chart. So 4177, 4,177. And this is in thousands. It's too bad it didn't tell us which city it is. I'd like to look that up to see how true it is. The estimated population in 2020 would be 4,177,000.